All right. So all right. Are you able to see my screen and hear me clearly, everyone? Great, great. All right. So before we start, do you have any questions for me? Yes, no, no questions? All right. So let's start with our usual discussion. Okay. So so far we have discussed how to manage files when there are too many or too huge, and I mean data in the form of files, how to store them. Second thing which we have discussed so far is okay. Second thing which I have discussed so far is the 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 way of getting something executed in the network. Okay. All right. It looks like some people are facing issues in joining. Okay. All right. Okay. So we started with understanding what is big data. Then we try to understand how to store humongous files or huge data in the form of files using HDFS. Then we try to understand how yarn and MapReduce works to execute our logic or our programs in the network nearer to the data. Then we also talked about the zookeeper, where the coordination, we try to understand how to do the coordination and between the processes and programs running on different machines, and try to understand the limitations of everyone. And then we also talked about pig and hive, where it becomes easier to execute the query in a distributed way. Then we talked about Hive and NoSQL. All right. Then we talked about Hive and NoSQL last time. Okay. No, not HBase and NoSQL. HBase and NoSQL as in how to store data in the form of table when you have too many edits coming in, too many modifications, updates are coming in from various sources, and the data is really huge. In those cases, how to manage it using HBase. Okay, so we understood the architecture of HBase. We understood how NoSQLs give you the advantage. All right. Now the next thing which we would like to finish the remaining parts of HBase, and the entire focus. All right. So looks like the voice is breaking. Let me see if it is the problem with the tool. Okay. All right. All right. Okay. So looks like I'm in the right mode. Okay, good. So let's try to understand what does it mean by Bloom filter. Okay, the Bloom filter is a way of distributing the search. I'll try to explain this part. All right. So in HBase, when there are too many rows, remember every row had a row key, and whenever we have to search, we will search on the row key. When the data in the rows become huge, the usual index is also insufficient. Okay, how many of you have faced in past that the table has become really huge, that indexing a particular column takes a long time? Has anybody faced this situation? Right? So in the same way, looking up in a huge index in a column which is huge becomes a challenge. That's where the the data structures like Bloom filter come into play. Although you will not really need Bloom filter, you would not really need Bloom filter, but it's a interesting question, and people love to ask this during the interviews. Okay, also it's important to know such concepts because they come in various forms and various shapes at various in various kinds of products. Okay, so let me just turn off the fan. All right, here we go. So imagine that there was a single there was one person. Okay, let me should I draw it for you? Okay, let me see if I can draw. Okay, so imagine that there was one, let's say, watchman. I'm trying to draw it. I hope I'm able to make it look like a watchman. Okay, so he basically had too many requests coming in for him. So okay. So his role as a watchman or a security guard is that people come to him, okay, tell the name that, hey, I'm Sandeep, hey, I'm Jitendra, I'm Kush. Can you allow me in the entry? Okay. So many people come to him, and he basically looks into let's say a huge, he has a, okay, so let's say he has a huge uh, kind of notebook in which there is a names of everybody written. Okay, and there are quite a few of those. Okay, let me try to draw it as if it's really huge. Okay, and all right. Okay, so there are many pages to this book, and all right, so it's really huge book indexed by the first name. So when people come to him, and these requests that are coming to him are coming from the users, and all of them are asking, is my name in the book? Okay, so basically, let's say this is Abhinav, and let's say this is Abhishek, and let's say this is say, let me just see some names here. Let's say this is Arsalan and Anup. Okay, and we have Jin and then Jitendra. Okay, these are the kind of people who have come to ask, right? Now, in this name, what this person has to do is he has to look by the first name. Luckily, these names are ordered. This whole directory is ordered by the first name of the people. Okay, so now he realizes that no matter how fast is he, is going to take a long, long time. Okay, it's going to take a long, long time for these for checking the names of these people. Now, so even though the data is indexed, which means that all he has to do is just jump into do the bisection, as in binary search, as in open this directory in the midway and then see if Abhinav is on the left or the right, and then search only in that portion of the directory. Okay, that's binary search. But since the directory is so big, the binary search itself is taking a lot of time. All right. So what they do is they come up with this scheme that let's have two watchmen. One watchman to do the preliminary filter, and second watchman to do the rigorous check, to the actual check. Now, how do you prepare the preliminary filter, the primary filter, or you can say the cursory? Somebody who is just checking but is not sure. Okay, a way of checking where he can confidently say no, but he can't confidently say yes. Okay, that's where the Bloom filter comes into. So a small directory is prepared out of the actual directory. Okay, let's say we come up with a scheme that there are two watchmen's. Okay, two watchmen's, which are one who is doing the cursory check. Okay, let's say he's just looking at first three letters of a person's name. Okay, so out of the Hughes dictionary, what we do is we just picked up the first three letters of every name and prepared a small directory. Okay, out of the Hughes directory, we just picked up first three letters. Okay, which means how many? Okay, so if we are talking about first three letters, first we picked up first three letters of every name from directory and prepared a new directory. So how many names would be there in this new directory? So we picked first three letters of every name and prepared this. How many maximum would be there? So 26 into 26 into 26, right? Only these many names. Out of billions of people, this new directory would only have these many. Okay, and searching for this kind of name, this kind of index having around 17,000 records is far more easier, right? Or let me just say that only two letters. Now, if we say two letters, it will become further smaller. So there will be around 576 letters. Okay, does it make sense to you? 576 names in total. So that's called Bloom filter. Bloom filter is essentially, okay, yeah, that's right. It's 676. Thank you. Yeah. So is everybody with me? All right. So the problem statement is that even in the scenarios where the binary search is a tough, is still very difficult to do because of various reasons, because data is in the disk and data need to be read in order to compare. Okay. So binary search or B trees, they don't do great when it comes to humongous data in the disks. Okay. So in those scenario, you need Bloom filter. Okay, Bloom filter is nothing but it's basically a preliminary check. Preliminary check to defend against the false names. If because if the watchman is bombarded with false names, it'll quickly check if it exists in the dictionary directory or not. All right. Let's take for example here. In the directory, you have Abhishek, but not Abhinav. You have Arvind, but not Arsalan. You have Anup, okay, and you have Jin and let's say Jin. Okay, only these people are there in the directory. So and there will be many more. So just for the case, just for the discussion sake, let's say that we only pick up two characters of every name. So the new index, this is the actual directory. So the new index will look like this. So it'll be AB and AR, AN, and that's it. Okay. So it'll look like this. Okay. Although there'll be lots and lots of, let's imagine for time being, there is Abhimanyu and there are, okay. So so you can see that for Abhimanyu, there is no additional name. So it'll be very small directory. Okay. And you can see that it can fit into maybe 3-4 pages. Okay. So another watchman. Okay. How can I select him? So the another watchman would be given this list, and most of these people will first go to him. Okay, most of these people would first go to him, or let me make it a little nice. Okay, so all right, I think the other example is here. Okay, so you can see that here I have taken another use case. The actual directory contains the name like Midhili, Bispa, Mahesh, Mamta, Abhay, and there are 1 billion such entries. Okay, so out of this, we have just prepared this small list of first two letters, Mai, Bai, Ma, Ba, and AB. And when, let's say, Abhinav comes and asks, am I in the list? Okay, he says, yes, you are in the list, but when actual checking happens, he's not really in the list. Okay, so Abhinav, because AB exists in the small set of letters in the Bloom filter, it will say yes, you are in the list. Then the actual checking will happen, and then it'll return yes, you are not in the list. Then Mamta, for Mamta, MA, are you in the list? Here, the first Bloom filter says yes, you are in the list. This is the new watchman who came in, and then the person is redirected to the actual watchman, and actual watchman says yes, he's in the list. Okay, for Sandeep, it is for Sandeep, it's rejected by Bloom filter because SA does not exist in this list. Okay, is the example clear to everyone? Now the question is that why are we preparing only first two letters? Why not something else? In reality, we don't do it that way. Instead, we convert every name into a number using a hash code. Okay, and therefore every number becomes an integer, and that is what is used in case of Bloom filter. Because when you convert a huge name into the number, it becomes the whole list becomes very small, and it's easier to search in the numbers than the names. Okay. All right. So this is Bloom filter. Okay, so Bloom filter essentially is in case a particular key does not exist, for sure, the filter will reject it. Okay, but in case filter says yes, you exist, that does not really means that it exists because it has to be checked against the real storage. Okay, so filter can for sure say no, but it cannot for sure say yes. All right, any questions on Bloom filter? So Bloom filter is a general data structure to assist in the searching in the case where the indexing is not really much of a help. Okay, and in case of NoSQLs, Bloom filter comes as a very useful, very useful data structure. Okay, so Ali's question is, where is Bloom filter implemented? Mostly, Bloom filter is Mostly, Bloom filter is implemented by the service or the database itself. And there are some third-party services called Bloom filter. You can use those as well. Okay, just for the for making the querying faster, you can enable or install separate Bloom filters. Okay. Bloom filter basically is the way you have a data structure called hash table in a distributed way. That's what is called NoSQL data stores. Similarly, Bloom filter also comes implemented either in the NoSQL or there are, I think, independent Bloom filter tools. All right. So that's an important concept. By default, in case of HBase, Bloom filters are enabled. Okay, and Bloom filters can be enabled per column family. All right, and you can. There are three modes in which you can apply Bloom filter in HBase. One is where the Bloom filter is based on the row key. Okay, based on the entire row content. Okay, so the Bloom filter by default is based on the row key, and you can apply the other kind of Bloom filter whereby row and column, as in column family along with column name, are also used while computing the hash. Okay, so that's also another way of applying Bloom filter in case of HBase. Okay, if you want to dig deep, you can take a look at these URLs and they will answer your questions. All right, so that was Bloom filter, and HBase comes with something called coprocessors. In case you want to enforce permissioning or other kind of data sanities, you can use coprocessors. Coprocessors are like triggers. You remember triggers? In the database, you generally have the triggers. Triggers are piece of SQLs that get executed, a piece of stored procedures, you can say. They get executed as soon as they get executed when the data get modified or before or after the data get queried or modified. Okay, so you can use Java to create a coprocessor and set it in the HBase. All right, now there's a question from Jitendra. It's a good question. All right, question is, will it increase execution time since it needs to go through two indexes? Anybody who can answer this? Yes, so here you can see that earlier there were only three querying, right? There are one, two, three. Three user came in, right? So earlier, if there was no Bloom filter, there were querying happening only 3 times, right? But then after we have implemented Bloom filters, 3 plus 2, 5 times the data index or data was queried. So do you think it is better or it is worse? Anybody? Anybody? So earlier, if there was no Bloom filter, all the users will basically hit the storage, and we will check in the storage and respond. Okay. Yes. So why it is better? Because even though now 5 queries instead of 3, so on an average it looks like it'll take more time. But this data set is so small that it can be maintained in the memory. And you would be amazed at the part that 90% of the queries will be rejected, or 90% of queries will be answered by the filter itself. Okay. In the cases where it's negative, whether the key does not really exist, most of it would be answered by the filter itself. Okay. So imagine 90 requests coming like this, and 10 and 10 coming like this. So for 90 requests, the actual data storage was not hit. So answer was instant and prompt. For say 5 requests out of 100 and 5 requests out of 100, the query has to go till the data storage. So in those cases, there will be a little bit penalty here. Okay, but it'll be in milliseconds, and therefore it'll be insignificant. Okay. Yes. Thank you, Manjunath. Thank you, Jen, and thank you, Ali. All right. So was I able to answer your question, Jitendra? It's a good question, and interviewer, that will be the interviewer's second question. So Jitan's question is, will it always be in memory, or developer need to plan it? A Bloom filter is generally created in the memory. The reason is that Bloom filter, since it has to be updated on every modification to the actual data, it's easier to update the Bloom filter. Second, since the data filter carries is generally small in size, if it's not small, make sure to make it small. In case you're computing hash code, or the scheme that you're using, use it such that your data becomes really, really small. Okay? And there are many strategies that are followed in case of Bloom filter. For example, it'll be created like a massive array, and the key that you're looking for would be the index of that array. Imagine a huge array. Okay, so can I draw it? This is a very interesting question, and this is a favorite question of many people at Amazon. And if you take a look at more data structure questions, so that those questions will be you know. Okay, so I'll explain to you. Let us say that, okay, uh, Abhinav, okay, when the hash code of Abhinav is computed, it would be, let's say its hash code is say 102. Okay, the the Bloom filter would look like this. Okay, be with me for a minute. Okay, so Bloom filter generally, although I gave you a very rudimentary example, but Bloom filter would be something like a vector. I'll try to show you. It is a Boolean vector. Okay. So instead of saying AB out of Abhinav, we converted Abhinav into a number called 102. Okay, 102, or say 10, by maybe summing up the letters, dividing by 100, taking the remainder, or howsoever. Okay, so let's say here the hash code is say let's say not even 12 for the argument's sake. The hash code came out to be 12. Let's say we summed up all the letters of Abhinav, divided those by say 54, and whatever is the remainder is the hash code, which means there could be many names having the same hash code. Okay, now here let's say this one is 1, this is 2, this is 3, this is 4, and this is 5, this is 6, 7, 8, 9, 10. Or let's say these are okay, and similarly there'll be more. So and here just for the argument's sake, I'll make it 6. Hash code of Abhinav came out to be 6. Okay, so we basically would directly jump here and check whether the value is 0 or or say false. Okay, so this array is kept in the memory. Okay, so generally a hash, the way Bloom filter is created is in the form of a bit array of huge bit array. Okay, it contains yes or no at that particular number. So if let's say somebody else comes, say Jitendra comes to ask, okay, so it'll be like very simple. You say Jitendra, and Jitendra has code is let's say 7. Okay, and you basically jump instead of here, basically jump directly here. Okay, is this concept clear? All right, because when we say RAM is a random access memory, which means it's very easier to jump at a particular element in the array and give the answer instead of scanning through it. As opposed to the disk, where you really, if you have to jump from one location to another, there's a physical movement and that takes time. All right. So Bloomfield is generally implemented like a huge bit vector. Okay, and lots of problems can be made faster by the way of this translation. Okay, and and generally these are the favorite questions of people. Let me ask you this. Okay, let me ask you this. Let's say let's say uh, let's say you have to implement the fastest way, okay, in which you have to sort the data a data data by the age of people. Let's say there's a huge list. Okay, there is a huge list. Okay, what's the date today? 3rd December. There's a huge list. Okay, and what was I talking about? Yeah, question is, how do you sort the data by age? Let's say census data. Okay, let's say there is a data that contains the age of people, name, And how do you sort the people that data by the age? Fastest way. Anybody? Manjunath says bucket sort. Okay. And age is in years. Age is given in years, not in months or days. And I'll make it further complicated. These are say 10 billion records. This again a very interesting question which everybody likes to ask. So the answer is you prepare a similar model like a array. Okay, so what you do is you basically create a huge array. You create a huge array. Okay, the age is the index. You start with 0, 1, 2, 3, up to say 150. Okay, or maybe 200 because there has been no user whose age is more than 150, no person. So which means that you can safely um, you know keep these as numbers. How many people at 0 is, let's say 5, and so on. So you can go through the list of people, prepare this vector, and then just go through this vector and say that these are the people, these are the records that are of. Okay, so this is another way of okay. Or what you can do here is that if there is a record ID of these 10 billion records, you can simply keep that ID here. Okay, so basically a lot of problems either can be solved by this kind of model. All right, good. A question from Jen: does Bloom filter have multiple labels? Not generally. Okay, but Bloom filter generally have one label only. So I think Bloom filter is enabled by default. Let me just check. I think Bloom filter is enabled by default in case of Hadoop. Okay, and I'm trying to answer Ted's question. So you generally, I mean, if Bloom filter is not by default enabled, make sure that you enable it by. Let me see if there is a way to toggle grade. I'll have to check from the console by saying describe a particular table, and then it'll show us. Okay, so by default, I think it's enabled. Now, bigger question is why do we need to turn on? Is there a specific data size to consider? When the data goes beyond few 100,000, okay, then you consider enabling Bloom filter, because up to say 100,000 records, you don't really need Bloom filter. Okay, because the usual index querying is fairly faster. Okay. Ali's question is, so we generally need Bloom filter for every searchable column. It is up to your need. Okay. By default, it is enabled based on, I think, the row key, but you can enable it along with the column. All right. So yeah. A question from Jiten. This should actually be enabled when we expect queries with non-existing data. Both. Yes. So lot of querying actually on a table in an organization. Lot of querying happen on non-existing data. So if that's also one sign when you are having, even if your records are smaller, and you are having lots and lot of query on non-existing keys. So you can suddenly cut down that noise by enabling the Bloom filter. That's also a good way to look at. Even if your data is smaller, but number of queries are coming higher, and there is lot of non-existent data is being queries, in those cases, you can generally enable the Bloom filter. Okay, good point, Jitendra and Tad. All right. So this was our discussion on HBase. So HBase also provides something called REST interface, which means you can query using the URL. It provides it provides a URL scheme whereby you can specify everything in the URL itself and via the browser itself. Okay, to enable the REST interface, you can simply say HBase REST start -p4040. Okay, so this basically would give you a JSON object. Okay, so when you, yes, these are called RESTful interface. RESTful APIs or RESTful interface means that they follow certain standards with respect to HTTP. For example, when you want to query, you use GET. When you want to make changes, you use PUT. Okay. Similarly, every state represents a URL, the separate URL, and the data related to the user session is not part of URL. Okay. So those are the standard parts of REST. Okay, and you can simply log in into console, enable it, and then query it using this kind of URL. You can see if you are on E and you have started on 4040, or let's say 11111, or let's say 4040. 4040 is a good idea. If 4040 is busy, try something else, and then okay, so you can do. All right. So, okay. So Bloom filter by default is set as none. Thank you, Manjunath. Okay. Yes, that's right. So I was wrong. That Bloom filter is not enabled by default. So you can enable it by on the key or others. All right. Good. Thank you, Manjunath. All right. So you can query using the URL itself, and this is quite useful when you are trying to query the data in HBase and display it in the graph or charts. All right. Sometimes you may want to use a JDBC connection to HBase. In that case, take a look at Phoenix. It's a Apache project to let you query using SQL in the HBase. Okay, as well as you can use update and mm, insert commands using SQL. All right, so that's pretty much with respect to HBase. So Manjunath's question is Bloom filter created for each flushed file? I don't think so. Bloom filter is created on the table, as in per column family basis. And yeah, okay. So this was HBase, and okay. So any other questions with respect to HBase? No? All right. So that was HBase. Now we are moving ahead into, we will start with our discussion on Scoop, and then we'll talk about Freum. All right. Okay, a question from Jen. I lost track the coprocessor part. So coprocessor is a idea, although I don't have a ready-made example without the programming part. So coprocessor is a feature of HBase in which you can create your logic. Okay, just like triggers, you can create your logic which gets executed at various points, such as before put, before get, as in, and after put, after get. Okay, so that's the coprocessor. And yeah, a question from Manjunath. Can you explain CRUD operations? CRUD means create, retrieve, update, and delete. And it doesn't provide a query per se. Okay, so the commands that we were using in case of HBase, I'm going to log in into E. This time I'm not using web console. I'm just using my SSH command. It's the same. It is same thing as using the web console. Okay. So here we have this. So here we, okay. So this is my console. I'm saying HBase shell. All right. It's connecting to HBase. All right. So the entire CRUD operations happen through one. So C happens through put, as in when you want to create a record, you use put. C or U, create or update happens through put. If the same column, same cell contains previous value, that gets overwritten by put. Okay. And the retrieve part is something tricky when you want to search. Okay. When you want to search, then you generally use MapReduce. Okay, in Java. Third is when you want to delete a particular record, you basically have a delete command. All right. So you can see, I'll show you. So you can type help and it'll show you all kinds of all operations that are allowed on HBase. Okay. So DML means data modification language called append. It has append, count, delete, delete all, get, and put, scan, and truncate. Okay. So these are the various commands available for data modifications. All right. So these are rest are for the administration. Good. Was I able to answer your question, Manjunath? Manjunath's question, I just wanted to know from HDFS perspective. Okay. All right. So when we create a record, so as I showed you, the file has the HDFS file has something called paddings. Okay. So every row, every file has padding. So if you're trying to modify, you'll basically update the same file. And yes, HDFS does provide ways to modify a file. Okay, modify a file uh, if you're just replacing exact bytes. All right. So yeah, so it uses that special HDFS API to update those particular files in which the records are kept. Okay, just like any other database, the way, let's say, MySQL or Microsoft SQL behaves, that for every record or every column or every cell, it keeps some extra space. Okay, it reserves some extra space. So if you modify something, it basically, instead of creating a new file, copying the entire data there, it just fills in the remaining part. Okay, in the padded part. All right, so that's how it works. All right, good. Did I make sense to you, Manjunath and others? All right, so too much of theory. We will next try to do everything hands-on. It might take a little more time, but we are okay. All right, and that way we will all learn how to get things done. Okay, lot of basic questions get cleared while trying to do something else. Okay. So what is Scoop? Scoop is an open source tool. It extracts data from databases, meaning structured data stores. And when you want to put that data into Hadoop for further processing, Scoop can be of very much of use. It can move data from SQLDB to HBase. It can export data back to SQL data store and has extension framework called connectors. All right. So it is nothing but a Scoop is nothing but a wrapper on MapReduce command. Inside, it actually executes MapReduce. Somebody has written a special purpose MapReduce program, which essentially copies data from MySQL. All right, using MapReduce. Now, it's a it's essentially Java program that talks to your database via MapReduce and gives you the results. Okay, so few questions. So it's a Scoop is basically program MapReduce program, which means it's going to run using that MapReduce framework. So your connector logic, where you will connect to MySQL, MS SQL, will it be in the mapper or the reducer? So Scoop, inside Scoop is nothing but imagine that you want to copy data into HDFS and your data is humongous. One way is that you make one machine busy in talking to MySQL and then pushing that data to HDFS. Generally, your databases are really powerful, so they can handle many queries parallelly. So you come up with the idea, let's create a MapReduce program which will talk to the database, pull the database, and write to HDFS. So yes, all of you are right. That kind of connection logic would be inside mapper. And will there be multiple mappers or single mapper? Here, remember that the input file is almost, there is no input file. Okay, there is no input file as such because the input is going to be from the database, right? So when you are running MapReduce, this scoop, you are actually running a Java MapReduce program which has some logic defined by scoop, which will connect to the database, pull the data, and push it to the HDFS. That's all it is. Okay. So these, how many mappers would be there by default? If you don't specify in this case. Okay. So by default, there will be zero mappers because the input file is not there. And therefore, you will have to, and scoop will have to, scoop internally keep it one. Thank you, Manjunath. So scoop internally set it one as the default mappers, and you can change those number of mappers, okay, while using scoop. All right. A question from Anup is, will export be using reducers? Okay. Do we need to? Can we not save data directly from mapper itself? So we are just copy pasting the data. All right. We're just copying the data from MySQL and putting it in the HDFS. All right. So therefore, there will not be any reducers. All right, let's jump in. So we will try these things. We'll try MySQL to HBase. First, we will try MySQL to HDFS, and then HDFS to Hive, and then directly from MySQL to Hive. These things we'll try, and also we'll try MySQL to HBase and back. All right, these are the things which we are going to try. Okay, so Scoop provides connectors. It's nothing but like your database connectors or drivers. Those you can generally create, and generally any database which is JDBC compliant would be compliant with Scoop as well. Okay. Now, by default, we okay. One more thing. So when we said there would be multiple mappers talking to database, so we'll have to make sure that your database, the database, is accessible from all the machines. Okay, this is a big mistake which people do, and all the people who come after practicing at virtual machine, they can't really figure out why their scoop data is not being imported, because they don't realize that MySQL and the mappers would be on different machines. Okay, and I saw this big mistake with most of the people. They always considered that MySQL would be running on the same machine, so they always kept on giving local host here, local host here, and then they were wondering why it did not work. Even if they specify the IP address, they did not realize that MySQL database need to be accessible from A, B, C, D, and E uh, database machines. Okay, and that was what, you know, reason behind these scoop script failures. All right, because mappers could run anywhere on these machines based on the availability of the resources. Okay, therefore the call to MySQL might go from A, B, C, D, or F, or G. Okay, so let's jump in. So by default, we have created this database for us. Okay, you all can check. I'm also going to check if it's working. So I'm connecting to MySQL. This is my user, and this is the password. Did it connect? Oh, I think we need to change it to C. c.cloudxlab.com. Oh, sorry. Am I connected? Looks like I got disconnected. I am on my local host. Are you able to hear me? All right. Okay, good. So I'm still connected. I'm logging into my e.cloudxlab. All right, good. It's connected now. Now I'm going to use this command. And what is my password? Good. So you guys also can try this. All right. This is the password. Do not share the password with anybody. Okay. So you can see that there's a database called ScoopX. I've already created this database, and we are not allowing everyone to create the. Yes, you have to use the web console. So first in the web console, you run MySQL -u and then see the command, run the MySQL connection, provide the password nhkkp and something, and then say use ScoopX. There you will see a lot of tables. Okay. We have already done this part for you on ScoopEX. Okay. And I'm not sure if I'm allowed to create a database called, let's say, November 5. Okay. So we are not allowed to create database. Okay, but that's okay. But we can create our own tables. And for the sake of discussion, I have already created a widgets table. Okay. So I've already created a widgets table. If you want to create your own table, okay, with some other name, you can create. All right. So is it all right? So what was 172.31.1.3.154 is basically the IP address of c.cloudxlab. Okay, you can see these details. Okay, c.cloudxlab 173.31.1.3.154. Okay, good. All right. Is everybody able to log in and see the data? Yes, we are trying to. So what is it that we are trying to do? We are saying MySQL, this is my username called scoop user. And then 172 is the IP address. This is the c.cloudxlab that we are trying to connect to. And then -p means we want to provide the password. And then we provide the password. And then change the database using the use command. Okay, like this. And then execute select star from widgets. Good. All right. Also, in the MySQL credentials part, you have the host name and the login password. Okay. So are you connecting from your local desktop or from the console? First log in into SSH or using the web console. Then from there, you try this. Yeah. Local desktop, we have stopped it, stopped the access. Otherwise, there'll be too many attacks. Okay. So is it not prompting you for the password, Karthik? Karthik, you are on E or F or G? I see. I see. So let me try if it's working from the other machines as well. I'm saying SSH. Um, I have another administrator account. Okay, so what do I need to do? I need to log in. All right, I'm able to connect from G as well, F as well. Okay, everybody able to see the data in the MySQL? Yes. Use scoop ex, and then in there you will see the show tables. Okay, so select star from widgets. Good. Now let's leave this terminal open, and okay, or let me just exit from MySQL for time being. Okay, so we all checked that our data was there in the MySQL. It looks like this. Now let's try to import this data into HDFS. Okay, so this is the command which will do the magic. Okay, so let's try to explain the command. What does it mean? We are saying scoop import. Import or export is always with respect to the big data side. Import means we are trying to import data from MySQL into big data side, which is HDFS right now. Connect to this particular host. Okay, you can see as and this particular database, this table called widgets, and we are saying use two mappers. Okay, minus m2 means two mappers. This is the username, this is the password. We are saying split by id. By even if we don't specify split by id, it'll try to figure out the id from the table name. Okay, so again, what does it mean by split by id? Because it's going to have two mappers, right? Some of the records will be pulled by one mapper, some of the records will be pulled by another mapper. And the division is going to happen based on a column called ID. Okay, so here we go. I'm going to paste the command. Yes. All right, let me try first and then we all can try. So here we go. It says scoop import and that's it. It should give one error saying widgets already exist. By default, it will create a folder called widgets in your home directory and will try to import it. Oh, it's running, which means we have already deleted widgets table. Okay, so let me take a look in Hue if it's okay. All right, so you can see. Okay, let me explain that. Where is my Hue? Hue is already opened. All right, so let me sort my data by date, and there we have widgets. Okay, so this is just now created. All right, so you can see 4, 5, and 6 were in the first mapper, and 0th mapper would get the 1, 2, 3. Okay, so you can see this. So all the records have been imported into the folder called widgets. All right, question from Karthik is, can you explain the statement again? Definitely, definitely. So here we go. Scoop, import, connect to this particular database. Okay, this is the host. This is the host, you can see. And this is the, we call it JDBC URL. Okay, this whole thing is called JDBC URL. Okay, table is widgets, am2 username this, password this, split by ID. Okay, so Karthik, did I explain? Was it? Do you have a specific question about it? So import by default will create a folder called widgets. Okay. Yes, Ali, that's right. Saptrisi M -2 means two mappers. Okay. If we say three, there'll be three files. Okay. Thank you, Kush. All right. So who all are stuck? Let me try to share the screen. Okay. You can try to share the screen. All right. I've stopped sharing my screen. You can share your screen. Yes. Table name in MySQL is widgets. All right. Let me see if just a second. Let me drag this thing to the other side. Okay. All right. So just a second. No, no, no. You have to run it outside MySQL. Okay. Scoop is not MySQL command. It is a Unix command. Thank you, Sapna. Yeah. Yes. Now run the same command. Enter. Ouch. Looks like there's a new line somewhere. You'll have to uh, copy there is a new line between the password. See? So remove that new line or copy paste the same message again. Okay, good. This is correct. This is correct. Looks like it has started executing. Good. So it's importing data from MySQL into HDFS using two. Wonderful, wonderful, great. Anybody else stuck? Okay, good. So everybody is able to do it. Wonderful, wonderful. All right. Please check in the folder, either using this. Okay. Also notice that in your current folder here, there will be a file called widgets.java. Okay. This file you can reuse in order to automate the entire process. Okay. It creates the object, so you can basically reuse widgets.java in your piece of code, which does the import. Okay. So you can always think of it in this way. You can think of it in this way that MySQL records are being pulled by many mappers and data is going into HDFS. Okay. Is the diagram clear to everyone? So yes, Scoop created this file called folder called widgets and part M001, part M000. And this widgets.java, yes, I think you were talking about widgets. This is the file created by Scoop. Yes. All right. So let me move this slide a little ahead. Yes, you can modify this file and reuse it. It's exactly for that purpose. All right. Saptarish's question is, where can I see the Java file that you just mentioned? It is in the folder where you run the command, the local file. Okay, so you can see, you can use nano command to widgets, then you can see. Good. Ted is saying having some, no, it's not in HDFS, it's in local. Generally, the code is in the local folder and the data is in HDFS. So Tad's question is, he's having error input. Can I make you the can I make you the you can share your screen. Okay. All right. Actually, you were yes. Connect is good. Table name is specify the table name. I think your command got broken into multiple lines. Yeah. Yes. Now it is good. Press enter. Okay. So just a second. You are in. Okay. Okay. Scoop import connect. Table is widgets. Good. This is correct. -2 username is this. Oh, there is a space. There has to be a space between password and username. Yeah, thank you, Anup. You see dash dash password? Just before dash dash, you have to have a space. Yes. All right. Okay. Looks like this time it's going to work. Let's wait for a minute. Okay, so wonderful. So it's working. So you can see Hadoop FS, Hadoop FS space -ls space widgets. That's it. Enter. You see, these two files are just now created. All right. So everybody, great, great. So everybody is able to import data using Scoop. All right. Now, all right. Now the next thing would be, okay. Saptarshi is saying that, can you explain the split by ID part again? Okay, let me again explain. So when I say split by ID, what does it mean? So imagine that you were supposed to write the same logic, right? Same logic as importing data using multiple mappers, correct? Now, on what basis will you distribute the work? We said that we will have multiple mappers. It wouldn't make sense that they all try to copy the same records. Instead, let some records copy copy the data from ID 1 to 10, and some record copy the data from ID 11 to 15, and so on. Now, we will have to tell the scoop that use this particular column while dividing the work amongst multiple mappers. Okay? So this is saying that my key is the sorry, not key is the this thing. We are basically creating a logic inside every mapper to pick the records which are mutually exclusive. Okay, did I explain to you, Saptrishi? So Karthik's question is, so we can move from MySQL using Scoop directly to HDFS, also to HBase. That's correct. All right, let's try the next thing. Now, let's say you have to load this data in the Hive, okay? In Hive, and you remember what we had to do to import data from HDFS into Hive? We will have to first create a table and then run load command, okay? So, okay, run load command in Hive. Now, instead of manually creating this table, Scoop provides you to copy the structure from MySQL into Hive. So you can say create Hive table like this. Okay, you can say create Hive table, and it will create the Hive table. Okay, so it's reading from MySQL and will try to create the table in Hive. All right, let me show you. Okay, so let me see, select star from widgets. Okay, looks like it already has some data. Let me delete this widgets table and run the command again. So here I'm saying instead of importing data, I'm saying create Hive table only. Okay, it should only create Hive table. Jin's question is, can Scoop be used for ETL? No, Scoop is just for data in, data out. Okay, ETL is either done using MapReduce or using streaming, MapReduce streaming, or using Pig, Hive, or Spark. Okay, let me again try. Sorry, I only shared the command with. Okay, so Hive is taking a little time to connect, or we can actually open Hive from here. Okay, this is generally faster and easier. The console for Hive is little uh, restrictive. Now, widgets table is empty this time. Okay, so we've created it has created the widgets table. So in the, okay, we did not specify the, okay, the database. So it will by default create in the default folder. Okay, since while importing, we did not say where to keep it in Hive, it basically kept it in the default database. Okay, so you can see select star from widgets. It's empty. Now let's try to load the data. We'll say load data. I'll give all of you. You try doing it later. And okay. Okay, so here we go and execute. It says no matching file found. Okay, we'll have to give the absolute location user slash Sandeep Giri 9034. Okay, so it has imported data for me. Select star from widgets. Okay, so what you can do is you can specify your database name, and that'll be the right approach. If you have not executed yet, let me correct it. Let me see what is the name of the database. In case of scoop help, create hive table. Yeah, so the way you can say here, my dash dash hive database. Okay, that's a better way of doing it. In my case, my database that I had created was Sandeep Giri, and then let me see if it's working or not. And then we will go here, select our database, the one which I had created earlier. Not yet created. I think it's running the job. Okay. Okay, let it do the job. Yeah, now it's created. Nothing is there. Then I will. Okay, so all right. So create your own database in this command, which I have just now pasted. Okay. So I'm saying create table and then this. And then next is, all right, go into Hive, go into Hive from Hue, and then select your database. In my case, it's Sandeep Giri. So I'm saying Sandeep Giri database, and then run this command. Okay. So yeah. Yeah, don't use that path because you are not allowed for this. You're not allowed to access my home folder. So you will have to change what all the name of your database, okay, as well as the name your username here, okay. Yes, you have to give your own username, not mine. This is just for the okay. All right, and this is your username. Good. Okay. All right, so you can try maybe whenever you want. And if you get stuck, just let me know. All right, good. Now, moving ahead. All right, so in case of this step, there was little too much work, little too much work in the sense that I had to do many things. As in, first I had to copy the data using into HDFS, then create the table, then import into table. We could do entire thing in a single shot. Okay, let me delete this particular table. Okay, we can say drop table widgets. Okay, and then all right, it should disappear. Yes, it has disappeared. Now we could do the entire thing in a single shot. Okay, so first I did was drop table widgets in your, sorry, drop table widgets, and then I executed this command. Okay, and I'm sorry here, again, I have selected the wrong database. I should have selected this one. Okay. In my case, it's Sandeep Giri. Change it to your own database. All right, by default, you can see that it is creating only one splitter, one mapper. Yes, I'll paste the latest command. Let it finish. Not yet finished. So it's doing both the things, copying data into HDFS as well as loading uploaded data into Hive. Those are the two things it's trying to do. All right, it has, looks like it has created it in the appropriate place. Yes. Now I can comfortably, okay, change the name of the database if you're trying. All right. So that's how you, that's how you generally use Hive. Okay, let's take a break of 10 minutes and be back by, okay, break for 10 minutes and back by 9:53 p.m. IST. All right, so can we start now? Is everybody ready? All right, great, great. So we have been able to import data into Hive as well as into HDFS. All right. In a similar manner, we can import data into HBase. All right. So here the difference is that here we are saying the HBase create table, and then we are specifying the name of the columns that we want to import, and we are specifying which row key do we want to import into. Okay, what is the column that should be titled as row key? Okay, all right. So that's what. So let me try to show you that inside HBase we're going to create another table called widgets. All right. So I'm going to delete the widgets table from HBase shell. Disable. What's the name? Widgets. Or drop. Okay. All right. A question from Ali. So for Hive, we are not going to use two mappers. Do we need to? It's up to you. It's up to you. You can just simply say minus M here, minus M2, and there'll be two mappers. Okay. All right. Generally, you should utilize, if your database is big, you should generally utilize multiple mappers. Okay. And that is the right way to do the import of use data. Okay, so now we are trying to import the data from widgets table into another HBase table called widgets. Right now this table does not exist. It will create the table by itself. Okay, so we have deleted the widgets table, and when I say scan widgets, we should be able to, it should say that the table has been deleted or something like that. Unknown table widgets. Good. It is deleted. Now we go ahead and import this into widgets. Okay. If you want, but you have to give a different table name in HBase, right? So it says that creating missing HBase table widgets. All right. So it's importing data from widgets table. Let me also describe once more what is it that we're trying to achieve. Here we are importing this particular databases, this particular table into HBase table called widgets. This table is again being created because we deleted the previously created one. Here we are saying, since you remember our previous discussion, in HBase, it is must to have column family. You cannot add columns without column family. So which column family should this data go? Then we say that we are going into column family one. And this is scoop user and password for the MySQL. And this command tells that we are trying to import HBase create table. Now, the next important part is columns. Maybe some of the columns of this table you want to put it in column family 1, some other columns you want to put it in column family 2. So every scoop import command can only import into one column family. Therefore, you will have to use columns option, and then you will have to execute this command into twice. If you have two column families, you'll have to run this command twice with different set of columns. Okay, and also you have to specify what is that column that is marked as the row key. Here we are saying the row key is widget's name, and we are using only one mapper. Okay, so if I go here as well, I should be able to see the data. Okay, if I say scan widgets, it should be able to show me all the data. You can see that. All right. So what was the table name? This was the table name. All right. So you can see clearly that there is one column key, a row key called gadget. Then there is only one column family CF1. And inside CF1, you have price one column and ID. Okay. In the similar way, let's say we want to import more data. Okay, the remaining columns, or we want to import remaining columns, so we can use this. Also, please note that this time we will be importing into column family 2. These columns that we are specifying, they'll be going into column family 2. But please note that here we can have repeated columns. Okay, so we are putting ID columns in both just for the demo purposes. Okay, not here, we have to execute it on the shell. Okay, so remaining data will come here. All right. So right now only one column family is there and column family 2 is not yet there. Okay, now you can see it has now column family 2 as well. Is everybody with me so far? Okay. A question from Ali is why files in my widgets folder is deleted? Why? Because the two reasons. One, okay, it's a very important question and it's good that Ali noticed it. Okay. One thing to keep in mind when we say load data, it moves data from the HDFS folder to Hive folder. Okay. When I say load data in path instead of copying, instead of local, I'm just saying load data in path. Second thing to note is dropping managed tables delete data. 3, Okay. And third is by default, Hive tables using Scoop are managed. Okay. Does that answer your question, Ali? So by default, when we create these tables, they are managed. And when we say load data, it basically moved the data instead of copying the data. And when we drop the table, deleted the data. Okay, that's the reason. Not really, Ted. You don't need to create a separate table. All you can do is just change, just you don't have to create upfront your own table. Just change the name to say widgets underscore Ted. Okay, that should be good. All right. Okay, so everybody on the same page? All right. So I'm not going to do the reverse, although it's very much possible to do the reverse. Instead of import, next time you can do the export. Just that you will have to create the table in MySQL manually. Okay. And then you can do the export. You can try this by yourself. All right. So we have been able to import data from MySQL into HDFS, into Hive, and into HBase. Okay, you can try exporting. It's not a big deal. All right. Okay, so Ted's question is that he's getting this error. All right, so don't change this table. There are two tables. Okay, Ted, one is minus minus table here, other is HBase table. Change this part. Okay, in the command. All right, try again after changing that. All right, wonderful. So probably everybody is able to use Scoop, and it's very clear that it's not the usual ETL. It's basically just importing, correct? ETL is when you clean data, when you realign data and fit it into the structure, or you remove the unnecessary data or figure out the data types. So ETL consists of a lot of operations. Here it just input and output. Good. All right. So let's move on. Now, these are another interesting topic coming in, and this is something which going to I would love to I would love to have everyone do this along with me. Okay, why? Because the same thing is going to be needed when we do the Spark streaming. All right, great, great. These are small topics, so it should not bother you because these are very interesting topics. Okay, and these are very, very important parts to do the hands-on. Okay, so Saptarishi's question is, could you give a recap of how we loaded data into CF2? It's the same command, okay? Same command, just change the column family to CF2, okay? and change the name of the columns, and that's it. Good? Meaning these ID, widget name, and price went to CF1, and when we change the column names, the row key remained the same. Okay, and yes, that's correct. It'll match the row key and create one more column family and the columns inside it. Great. All right. Is anybody stuck or is anybody getting confused or overwhelmed with all of this? I would love to fix it right away. Yes. Ali, Anoop, Arslan, Barsa, Jamil, Jin, Jitendra, Karthik, Kush, Manjunath, Nitin, Omkar, Prashant, Sapna, Saptrishi, Stephanie, Sundar, Ted, Thomas, and Ramana. Okay. So Ramana is lost. All right. So at what part are you, Ramana? Okay. This command, did it work? Should I make you the presenter? All right. You can share your screen and I've stopped sharing my screen. That's correct, Saptarishi. When you load data into Hive from MySQL, an HDFS folder is created. You can use describe formatted on your table and it'll show you. Okay, so can you go up? A little bit more up. Okay, just here. It says scoop, import, connect. All right, table HBase. Okay, so you have imported into the default widgets table. Okay, and the one which I was also operating on. And you have said, okay, good. Now, you have basically overwritten the data. Okay, you can press up key, not there. This, yeah, just change the option called minus minus HBase create table. No, before that, sorry. HBase table, dash dash HBase table. Instead of widget, make it at widgets underscore Ramana. Not this one. You have to press arrow key. The mouse will not work there. Okay, it's a little slow, but yeah. So you see dash dash HBase dash table and then widgets. Change that to widgets underscore Ramana. Yes. Ouch. Okay. Yes. Okay. So now this table will be created and the data from MySQL will be copied. Only those three columns in the command, they will be copied to this newly created tables column family. Now open the Hue if you have Hue and yeah, go to HBase because we are doing it in HBase. Okay, so you can say data browser, next menu, data browser next to query editors. Yeah, all right. So search for your table name. Okay, so you can see. All right, so you can see that it has only one column family, CF1. right? And all the table is being copied. Okay, the data has been copied. If you execute the same command with cf2, it'll basically create one more column family in here and copy the data there as well. Okay, in the command you must have seen that we have specified column family, the column family as cf1, right? Yeah, you can see. Okay, Karthik, which command you are talking about, cf2 or cf1? All right, Ramana, is it clear now? Okay, actually the cf2 one I did not copy. So, great, great. So I'll share my screen. The command to log in into HBase was HBase space cell. Thank you, Prasant. All right, good. So Ramana, is it clear now? I'll try to copy the second command for you. Okay, where was the second command? Here. Great, great. All right, so everybody is with me. If you're stuck, just let me know, because most likely you will also solve some other people's problem. There will be a lot of doubts that come in, and it's better to clear the doubts now than later. Okay, great. All right, so this was what we learned today. Was how to copy the static data. Also, please note that there are a few questions here. Some of you, you should take a look at Scoop Help, okay? In Scoop Help, there are ways, if you let's say Scoop Help import, okay? Here, I'm going to put pipe more, which means it'll go pace-wise. Okay, so you'll see. Okay, are you not able to see my screen? I think I have shared my screen. I'll try again. I'll try again, okay? So desktop one, yes, this is one I want to show you. All right, there's one more question before I jump into this. And Saptarishi's question, Ted's question is, so for second column family, we specify another row key ID, right? It is up to you. It is up to your design. Generally, we keep the same row key, okay? Let's say there is a table. Some of the columns are supposed to go in one column family. Some of the columns are supposed to go in another column family. So generally, we keep the same row key, okay? We keep the same row key unless we are inclined to change the strategy, change the data structure. All right. A question from Saptrishi: if we want to execute the same process again, I get an error that HDFS folder already exists. It was corrected after deleted the folder in HDFS. In practice, how do we implement such repeated loads? Each time we have to go into HDFS and delete the folder. So yes, very good point. So generally we do that we delete the folder mostly. And the workflow tools like Uzi and others provide deleting the folder. But deleting the folder must have been in the cases where we were importing data into Hive or importing data to HDFS. Okay. So when you are copying data to HDFS, then it'll create the folder. If you try to do it again, it'll either you choose another folder or you create you delete the old folder. So when you create a workflow, let's say in case of HBase, you would not need that kind of problem. Even in case of Hive, you can do something like incremental. That's what I was coming to. Okay, so so sometimes what happens is you want to import data incrementally. Every day the table is getting created, and every day evening you want to import that data from MySQL, newly created data, into HDFS. So there you can say there would be one option. Okay, it's called I'll show you that. Okay, okay, so let me go up. So it's quite a huge yeah. So you can specify whether the table is going to be as a text file, this is the default, or in another formats. Okay, and you can select the columns, that's okay. You can also delete target directory. Okay, so yeah, I think that answers your question as well, Saptrishi. Okay, so you can have that. Next is, yeah, number of mappers. All right, now I'm trying to show you there was a very nice incremental. Okay, this option called incremental, what does it do? There could be two kind of modes called append or last modified. Okay, so let's say there is a date column on which we have to check and then uh, update data, right, every day. In those cases, you use last modified. And append is you just keep appending without having to worry. But in both the cases, you must have to have a column, okay, on which to check the last modified date, or on which to check what has been appended so far, and from that onwards we have to append further. Okay, so if you are going for the, let's say, append mode, incremental append, then you have to specify a particular column to check, okay, before appending. Similarly, let's say you want to import last modified and you want to just specify a value, okay, that upload the data after this particular date. Then you can specify what were the last date till which the data has been copied. Okay, so if incremental append is specified, you must specify check column. If you are saying incremental last modified, you must specify last value. Okay, does that make sense to you? All right. Okay. Apparently, this question was asked by somebody recently in an interview. That's why I'm answering this. As part of our CloudX Lab, somebody was asking these questions, so we answered, and he felt very thankful when the same question was asked in the interview. Okay. All right. So good. Good. Let's move on to Flume. What does Flume do? Flume basically pushes data continuously. All right. So Okay, so let me take a step back here. So far, what we did was we took relatively static data and pushed it into HBase or Hive. This is great. This mode is great. But imagine there is a continuous data being accumulated on many machines, and you want to continuously push this data into HDFS. Okay, a real use case, I'll give you the real use case. So when we when I was with Amazon and we are on on-call duty, everybody is supposed to be on on-call in a round robin fashion, no matter how senior are they at Amazon. So we were, what happens is all the servers that are running, all the servers that are running their website, they're running, they basically, they are handling part of the load. And when they're handling the partial load, some users are going to one server, some users are going to another, and so on. And when they're doing that, their requests are generating logs. Okay, all the users who are accessing a server, that generates a log. And this log is to be continuously monitored. We need to monitor. Okay, at Amazon, if an error occurs very frequently in last 5 minutes window, it creates a kind of a ticket, an alarm that there is particular error that's occurring in last 5 minutes very frequently. So the person who is on call will generally uh, take a measure to fix it and turn off the alarm. Now, if you have to implement it in any real scenario, you will need to bring the data, the logs from all the servers to a central place and then process it. Correct? And this log is being generated at a very fast pace. You can imagine at Amazon or any of these websites, you get lakhs of requests or hundreds of thousands of requests every second, from every minute, not every second. So you get thousands and thousands of requests every second, and in case of Amazon, and this every request generates say 20 lines of log. Okay, therefore there's a huge data that is being generated every second, and this data need to be correlated in real time and processed. Okay, and that's how we basically at Amazon, we quickly rectify the problem in case even before the user uh, reports it in like 10-15 seconds. Somebody, either it's a reactive measure, or there'll be somebody who is, either it's automated or manual, but the problem generally gets resolved by figuring out or reverting the code back for that particular change. Okay, so coming back to it, so in a lot of scenarios where you have a lot of machines generating data, that data need to be flown, that all of that data need to flow centrally to HDFS, okay, or centrally to HBase, or so generally it's centrally to HDFS, and where the data gets analyzed. This is where Flume comes into play. Flume is a distributed, reliable, and available system for efficiently collecting data from various sources. Okay, so now Flume is made up of source, channel, sink, and uh, source, channel, and sink. These three parts. Flume is made up of three parts: source, channel. These are software components. All these three. So by configuring different type of source, different type of sink, and different type of channel, you can create many different agent. What's an agent? On every machine which is generating data, all of these machines, we install Flume agent, and this agent is nothing but a process running in the background. Okay, it has three things configured. What's the kind of data that's coming in? Where should it keep it? and how should it save it? So it's like the USB cable, which has source, sink, and channel. Imagine that you could replace all of these three parts independently. So with only few connectors, you would have been able to charge all kinds of mobile. And that's the modularity Flume brings into play. Okay, that's the modularity Flume brings into play. let's say let's say you want to store data into HDFS as well as HBase from say tail is a command, okay, using which you can continuously chase a file using tail, or a network socket, or any other process which generating data. So you can create all kinds of permutations just by changing sink and source. And that's exactly the reason why this is essentially, all these three parts are modular. Okay, so you can connect these agents with each other. You can say that the sink of one is the source of another, which means you can chain the agent together. Similarly, you can also have a kind of a resilient, you can also join, you can have multiple sources, or you can the sink can write to multiple places. Okay, the sink could write to multiple places, and similarly source could absorb data from multiple places. So by combining the agents, you can actually form all kinds of topologies. Okay, so it supports the example of the source are tail. Tail is tail command basically reads data from a file continuously. As and when the file get modified, the data gets printed onto your screen. So tail minus f is a very popular way of monitoring the log files. Syslog is Unix machine process which runs in the background, which collects the log of the entire system. Log4j is Java way, and so on. Okay, so you can arrange the Flume agents into arbitrary topologies, and there is generally an agent running on each source machine. With tiers of aggregating nodes, the data flows on its way to HDFS. You can form the topologies such as best effort, okay, meaning just linear one, or end-to-end, which guarantees delivery. So first one is the best effort, as in if any of the if this node is lost, this data will also not get to the target. But in this case, if this machine is down, this data will flow to another via another. So this is either end-to-end or best effort. So you can create the topologies and build whatever kind of guarantee model you want to build. All right, so let's try to do a hands-on, and this is going to be a little more involving hands-on. Okay. All right, let's try to do this. All right, I'm going to. So I have my Flume folder. Inside this, I have conf folder, nano Flume properties. This is my file. Okay. All right, I'm going to copy this. I'll make it available to all of you. Okay. I'm trying to copy it so that I can make it available to you. I'm copying it to /tmp. Then I'm logging into the admin account and say Hadoop fs minus ls slash data slash flume. Okay, so I'm going to delete. Okay, so I'm going to say Hadoop fs copy slash tmp slash flume conf into data flume. Okay, sudo minus u hdfs. Okay, so this time this should work because hdfs is the root. Uh, Okay, so you don't have to try it because it's only allowed to this particular account to run things like hdfs. Again, we'll have to say sudo minus u hdfs. Don't worry, I've not yet, I'm just preparing data for all of you. Okay, now I think, good. All right, so let's try this. So you can download data from Hue, or you can simply say, okay, okay, I'm just going to move this flume to flume.-old. All right. All right. So now, all right. See, so everybody is ready. We will do the flume together. Okay. So because it's very important because we are going to use the same thing in Spark streaming. So it's important that we all work on this together. Okay. So first of all, let's copy the pre-prepared config, okay, to our home folder. Okay, data, flume, all right. So we're copying data to local, this particular config folder. All right. So, there should be locally, there should be a folder. Good. So we can go into Flume folder. Good. So copy to local and then cd Flume. Is everybody with me? Wonderful. Wonderful. And there, if you say nano conf slash Flume properties, okay, conf slash Flume properties, what is it that we are trying to achieve? We are trying to edit this file. Okay. It's a configuration file of the agent. Yes. So right now it says a1.sources. So a1 is the name of agent. You can keep any name here. Okay. You'll have to define what are what is the name of the sources for a1. What is the name of the channel? What is the name of sink? Once you describe it, then you have to say a1.sources dot you have to configure each and every source. You'll have to define each and every source. So here we are saying we are going to absorb data from Netcat, running basically a process running at this port at this at the local host. Okay, so you might have to change this port. I'm going to use uh, these many times 0. You might have to use 1, 2, or 3. So everybody can post their the port that they are going to use. I'm going to use this one. You can use something else. Okay, because everybody must have different ports. Okay, so that there is no conflict. At least on same machine, there should not be any conflict. Prasant is going to use 41. Ramana is 49. Okay, just change this port. Okay. Uh, Nitin and Jitendra, you are Nitin and Saptrishi, you have a conflict. Okay. Kush and Jin, you have a conflict. No, not really. Okay. All right. Good. All right. Good. All right. Don't change too much. Just try to keep it like in a nearby vicinity. Okay. Next is change the username. Okay. Change the username in this, meaning this is our sink. We are saying we will read data from this. We will write data to this. Okay. Here we have to configure the output folder. In my case, it's Flume data. So let me delete this Flume data folder. Okay. So Flume web data. Okay. I'll just delete. Okay. It's empty anyway. It's not empty. All right. Let me delete everything what is there inside this folder. Good. Now, all right. Good. And then we have to inform the channel about the source and the sink, both. Okay. So press Control X and press Y. It'll be saved. All right. Now, once you have saved it, change the location of the output file as well. Okay. You'll have to update this username because your home folder is /user/Sandeep. Your will be your login and then this. Good. Yes, Nitin. And also make sure that you have made I think you'll have to create this folder. Okay. In my case, it's already done. You can also create your own folder. Okay. So everybody with me? So first copy the file like this. Okay. CD into Flume folder. Nano this. Then after saving it, you change it. Okay. Good, everybody. All right. And then what we are going to do is we are going to run the agent. Okay. So here, all right. So you can also run your agent. All right. Okay, I'm going to paste it again, this command. Here you go. So this is, I've pasted the command twice. So we basically copied the config, then we went into the folder, we edited the file, then we created the home directory, then we are running the agent. Okay. Now once we run the agent, you will see something like this. For me, it's saying it is running at this particular port. Okay. Now you'll have to open another terminal. Okay. You'll have to open another terminal, or I mean the web console. Open one more web console. Okay. So at this point, open one more web console. All right. And now let's run a program to connect to that host, to connect to this server socket, which is listening on this particular port. Okay. There we're going to say nc localhost, whatever is the port. What is the port number? This is the port number for me. Your port number will be different. Okay. Okay. So this is going to be your port number. All right. So right now, this is what is this command doing? It's connected to this particular port. And who is listening on this port? Our NC, our agent is listening at this port. Our agent is listening at that port. Whatever you write to this port is going to save it in the HDFS. Okay? It's going to save whatever you write to this particular port. So that means that you have created a server which can listen to other processes and write to HDFS. So if you run this agent on hundreds of machines, they all will write to HDFS. And having said that, those who are on e.cloudxlab, they can write to this port, my port, and save the data in at a central place in my directory. Okay. So Ginny is saying, seems like taking time to start the agent. It should not take much time to start the agent unless there is a conflict in the port number. Okay. Here, when I say nc localhost, it's basically has started. It's just waiting for me to type the data. Okay. It's just waiting for me to type the data. And here, when it says that created this particular uh, bucket, right? You see, the created this particular socket, it is essentially listening and waiting for us to write to say something. Okay, so now you can see here when I refresh it, there should be some file here. You can see there's a temporary file in which the current data is being written. Okay, and what does this temporary file have? Right now it doesn't have much. Okay, it is temporary file is moved to the proper file now. Okay, so now let's take a look at it. So whatever I have typed here, JKJ is being written here in this particular sequence file format. Okay, so yes. Is it working? So whatever I type here on this side, whatever I type here is going to go into this folder. Okay, and then being written here. Is it clear to everyone? So this is my Flume agent which is running. Okay, what error are you getting, Saptrishi? Okay, so let me try to Java home not set. Interesting. That's okay. It'll figure it out by itself. So did I get a warning? See, I do get the same warning. That's not a problem. Okay. So Saptarshi, do you want to share your screen? Let's take a look. The command to write data would be nc localhost and then your port number, whatever port number you write. Okay. All right. Good. So it says that the specified configuration file does not exist. So go up one level, go up one cd dot dot cd dot. Okay, cd space dot dot cd space dot dot. Yes. Now run the same command again. Okay. Good. Now open another console. So now it has started server at 344. Okay. Let me also. You are on E or F? F. Okay. Let me log into F and try to mess up with your service. Okay, now you say ANSI local in ANSI space localhost, ANSI space localhost, space port number 3 and then 4 times, I think. Correct? Now, whatever you write here is going to go to your agent, type something, and yeah. Yeah. Now go to HDFS. Okay, refresh the folder. Yeah, you can see that the data has come here. See, first line, second line, you see there, because it's a binary data, it's in the sequence file format. You can see first line, second line. Great, great. Anybody else facing the problem? Okay. All right, Karthik is getting error. Jin, are you able to run it? Jin and Ali? Okay. All right. Now let me see what's going on with Karthik's screen. Karthik, could you share your screen, please? Okay. Permission problem, most likely it should not have permission problem. Most likely it is going to be the folder name is incorrect, or you have not created that output folder. Yes, Karthik, we can't see anything. Maybe you have shared only one particular screen, which doesn't have anything on it. Okay. So Karthik, can you share the screen? We can't see anything. Okay, share the entire desktop, that'll be easier. Yes, that's right. When we are connected via NC, NC is a general command which can be used for talking to any service. Also, NC is a very simple command that can be used to start a simple service. Okay. So Karthik, can you share the entire screen rather than only one window? Yes. Karthik, we can't see anything on your screen. Okay, good, good. Ali is able to do that. Great. So, Jin, are you able to do it? Wonderful. So, if you are able to do it, that means you have become good at running it. So, this is the first session where we are actually able to get the students to do it. So, Karthik, you'll have to click on share screen again. Okay. And click on desktop. Okay. All right. So, I'm stopping to share my screen again. You can click on share again, Karthik. Are you there? So Prashant's question is how long till it stops writing to the same file and start writing to the new one? That I'm not sure. It's a very like few seconds game. It writes, create the file for few seconds. Okay. Ted's question is, will the file be generated for multiple machines having agents? Will the files will be generated for multiple machines having agent? Yes. So all the files will be there for all the files for every agent will be created in the same folder. Okay. All right. So Thomas and Karthik, one of you can share the screen. I think Karthik is not around. I think he got disconnected or something. Okay. All right. Thomas, you can increase the font a bit. You can say Command plus. Yes, good, good, good. This is good. Yeah, you are able to connect to this particular port and start writing to it. Not here, not here, not here, not here. This is just the service running on the port. In the second terminal, second one, yeah, and next one, yes. There, if you type, that's it. Yes, press enter. Now let's go back to the previous screen, the tab number 4. What does it say? Does it throw some kind of error? No. Okay. Press enter again. Oh, run the previous command again. What's wrong with this? Type something here. Yes, now it's working. Now it's working. You can go to your home folder and check. Refresh it. Great. You can see thanks, great, and so on. Wonderful. All right. Okay. So Karthik, you can try again now sharing your screen. I see. So Jin's observation is that when you click on OK, the new file will be created. I'm not sure actually. If you're writing really fast, it is going to do this. So yes, so it's working, I think, for you, Karthik. Now you go into HDFS. Let's take a look. Okay. So do you have Hue open? Can you go to Hue? Looks like, yeah, it's working. Refresh it. Refresh this page. Yeah. Go back to the terminal where you started the Flume agent, console where you started the Flume agent. Okay. Go back to the console where you started the console where you have started the web console where you have started the agent. You have run the command called flume-agent. I think it's second last terminal or so. Before that. So where is that terminal where you are running the agent? Okay. So I'm just wondering, no, it would be open. If it was closed, you won't be able to connect to that. You won't be able to connect to that. Okay, so it is open. One of these terminals is that. Okay. Okay, let's open another console. Or you can just open CloudX tab and then open. All right. Okay. So open another console and open another console, Karthik. I think something wrong with you with this browser. You have Chrome on your machine? Okay. All right. Okay. So Jin says for me, it is after I hit enter. Oh, it's already 11 o'clock. I did not realize it. Okay. So Karthik, why don't we do this? We can take it offline. I think let's do this maybe. So give me a ping when you are free, okay? And we can do it. All right. I think you are almost there. I think the mistake you made is probably the location of the folder is not correct, and that's it. All right, Karthik. Oh, I wasn't. I didn't know that we have already crossed 11. Okay, so that's the magic of doing hands-on, that you don't realize that. So Karthik, you connect with me, then we will try to do it together. Okay. So is everybody able to run it? If you are not able to run it, just give me a ping. Okay, we will try to do it. Okay, and no worries, Karthik. So yes, the good part about doing hands-on is that you don't realize how much time it has passed. As opposed to if I'm talking, everybody would get bored and think that a lot of hours have passed. Okay, so Barsa is saying that connection timeout, which means that your service is not running at that particular port. You need to take a look at if it's running at that particular port. So why don't you do this? So Barsa, are you trying to connect to this app.cloud except from your desktop? So basically, okay. Okay, so basically this port, right, these numbers may not be accessible from outside, from different machine, okay, different machines. You know why? I'll show you why. Because if you go here, and the two reasons why it won't be available, okay. One, we are saying bind to localhost, okay. It's a very important point, everyone. Please pay attention here. So bind, when we say localhost, then this particular service can never be accessed from any other machines. Okay? Because localhost only is for the loopback, the local one. But if you want this service to be accessible from all kinds of machines, okay, then you have to provide this and allow this from allow this in the firewall. Right now, we have restricted all kinds of traffic to our cluster, and we have only opened selected port. Therefore, you may not be able to connect to this service from all machines outside the network. Okay, so this is important part. Good. Okay, so thank you everyone. It was a great session, and everyone is able to use Flume today, and Flume and Scoop, because this is something for importing and exporting data. We all got clarity, and it would be quite useful to all. Okay, great, great. Tomorrow we are going to start with Scala. All right, thank you, Saptarishi. All right, thank you, Arslan. Okay. Those who were not able to do the hands-on, please drop me a message. I'll try to connect with you. Yeah, or you can stay back. You can stay back, and we can do it right away. All right, Karthik, you can stay back, and then we can do it right away. Those who were able to finish it, they can leave. Those who want me to help, they please stay. I'll try to help you. Okay. Great, great to have all of you in the session, and I look forward to you for tomorrow's session. All right, see you tomorrow. Have a great day. All right, all right. So Okay, so those who want me to take a look at the problem, please stay back. So I'm going to stop sharing now. Karthik, now you can share. All right. Those who are done, you can leave. And all right, good. So let's open the two terminals. Refresh it. All right. Now let's try to run this agent again. The second command. All right. Just switch to another window. That should be good. Yeah. And show me the. Can you run the NC command again? The NC one. NC localhost. What was the port number? Yeah, this one. Enter. Good. Now that that connection is broken, which means you'll have to run the agent again. Okay, let's run the agent. Go to, okay, the second command is good. So from flume ng, just after console, little less. Yes, yes. Okay, yes. So one more thing, you will have to go to the folder called flume and then execute this command. Press Control U to clear this. Now say cd space flume. Great. All right. Okay, so you don't have this folder yet. Okay, so you will have to copy this folder. Say Hadoop, copy to local. I'll put it in the chat. I'll put the entire thing in the chat. Okay, you can see that. All right. Hadoop F, yeah, that's it. Enter. Now cd flume, say nano space conf slash conf slash. In Unix, you can simply press tab and it will autocomplete. Control X, I think you made a mistake. Control X. Yeah. Press up arrow key and press tab once. Up arrow key. Just press up arrow key. Click on the console. Press up arrow key. Yeah. Press tab. 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 Yeah. Enter. Good. Now change a few things. One, change the login to your login. You see Sandeep Giri in come down in that HDFS location. But before that, change the port number. Yeah. So 44430. Okay, that's your port. Good. That's okay. Yeah. Okay. Is this your login? Okay, good, good, good. All right, good. Yes, that's right. Now control X. Yes. Y. Enter. Yes. Now say Hadoop fs minus make directory mkdir and then that flume underscore web data underscore not dash web data. Good, it's already there. Now you can run the flume agent command here itself. Second one, yeah, second one from here till the end. Flume dash ng enter. Let's see what happens. Okay, so the service is now created. Now you can go to the second console and try connecting again. NC space localhost. Okay, refresh it. Copy paste the login, please. Okay, enter. Good, good. NC localhost. NC space localhost space the port number. Good. Enter. Nice, nice. Now open the hue. Open the hue. Good. Refresh it. Great, great. Now click on the file. So you can see that Karthik test, it has come. So it's a binary data. Look towards the right button. You see test dot 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 and then Karthik. Okay, yes. All right. So yes, you were able to create the file and yes, great, great. Thank you. All right. Before, great, great, Karthik. So you were able to do it. So Ramna, Saptrishi, you also have some question for me? Okay, great, great. All right, all right, all right. So I hope everybody is clear about what we did. So Karthik, you are clear about all the steps, what we did, or you just followed it? Yes. So part of the agent command is like this. So we are saying Flume agent ng. We are providing the configuration directory name. This is the config directory name. And this is a config files name. Because sometimes what happens is when you have custom parts, say custom source, custom channel, in that case, the library is picked up from this config directory. And this is the name of the agent. You remember A1, A2, what we had in the file? A1 dot, this A dot, right? So this is that name. And why is that so? This is something I forgot to tell in the class. Why is it so? Because what happens is when you have, say, network of 100 computers, right? So the configuration of all the 100 computers is kept in a single config file. And this config file is copied to all the nodes. Okay? And then while running on different node, all you need to do is change the command to have A1, A2, A3, A4, A5, A6, while all the configs of A1, A2, A3, A5, up to A100 is inside the same config file. Okay, so you are not maintaining multiple config files. Instead, you are making everything go through a single config file. So that's why we have to have an agent name. All right, and this is the log, this is the information, like what all information do you want to see on the screen, whether info or log or console. That's all. Is it clear to you now, Saptishi? All right, great. All right, so Ramana and Saptrishi and Karthik, see you tomorrow. Have a great day. Bye bye.